As John said, first of all, I want to thank John for putting this on, and I forgot your name. Ryan. I heard you're the reason we're here. So that's cool. It's a cool venue. Great speakers so far. So hopefully I won't let anybody down. I'll keep things going here. So my name is Jeff Roberts. You can reach me at any of these addresses. I'm on Twitter at Jeff B. Nimble. My GitHub repo name, or my GitHub name is Jeff B. Nimble. I'm going to have a demo with an application that I built, and you can get it there at GitHub, at my repo. Now I have two versions of the application. One is written in Objective-C. The one that I'm going to show you today is written in Swift 2. So, if you care, make sure you get the Swift 2 version. It's cool. A little bit about me first. I'm old. You can't already tell that. I've been coding for almost 30 years. And I started in 1986. And in 1991, I decided to go out on my own. And I've been coding as an independent software consultant ever since. In 2008, I joined, at the time, was a very small company called Riot Games. And I know Peter is a fan. I've been talking to him today. Riot Games publishes a game that has since become the most played game in the entire world, called League of Legends. And I'm fortunate enough to still work there as a consultant. And they wanted me to mention that they're hiring not only engineers, but all sorts of different positions, creative, designers, artists, etc. If you're interested, come find me tonight or tomorrow. I'm actually here until Wednesday around noon, so come find me. These are some of the languages that I've written in over the years. These are quite a few, and I've noticed I have to change text about every 5 years or so. Actually, if you play the game, if you play League of Legends, the front end is written in Adobe Air, and I wrote much of that.
I wasn't trying to troll you.
No. Yes, that's actually how I met John. Speaking at the Flex conferences. And as in 2012, I switched over to iOS. I've also done Android. Most recently, I taught my son to program. He is 22 years old. He's been coding now, don't laugh at this, but professionally for 3 years since he was 18. He's almost 22. So I passed on my passion for software development to him, and he's doing great. He and I together started a YouTube channel where we have little bite-sized videos about iOS development. And so check that out. Enough about me. Here's what we're going to do today. I'm going to provide to you a gentle introduction to functional reactive programming in ReactiveCocoa 3. I have a real-world application demo, which I'm going to show you here in a second. The majority of the time is going to be spent covering the core concepts of functional reactive programming, specifically with ReactiveCocoa 3. This is a topic that isn't specific to iOS. It's actually, there are versions of functional reactive programming in pretty much every platform. Android with RX Java and Java as well. There's React.js or something for JavaScript. It's pretty much everywhere. So these techniques, what I'm going to teach you today is pretty common across these platforms. Now, originally I thought I was going to have no time for my thoughts on this at the end. I thought I had 45 minutes, and I've practiced this several times, and I come in right at 45 minutes. Since we seem to have like 15 minutes at the end, I should have time to go over that and take Q&A. Couple of notes. First is, When I first started working on this application back in the summer, the early summer, I was using Xcode 7 beta because I wanted to write in Swift 2. So Melissa's talk on Swift 2 is going to be very relevant. I wanted to use a lot of the things she talked about, like the throws, the guard, the defer, all that kind of stuff. And I did. And it's in this demo application that I have. Most importantly, one of the things I wanted to learn was this technology that I'm going to talk about today, which is functional reactive programming. And in order to do that, I had to use the Swift 2 branch of ReactiveCocoa. They are in the process of coming out with a new version called ReactiveCocoa 3. Everything I show you is from that branch. So if you want to look at anything regarding ReactiveCocoa 3, some of that has been merged to master, but the documentation on that branch is what you need to look at, not what's on master. So I encourage you to go there and look at that. The second note, and this is unfortunate, and I think Brad touched on this a little bit, ReactiveCocoa has a significant portion of their API, which are extensions to iOS's SDK and UI components. So I'm not going to talk about those today. Those are written in Objective-C. They are extensions to all of these UI components like buttons and text fields and such, and other iOS components like NS Notification Center and NS User Defaults. And I'm not going to talk about those. This talk, I hope, is different than most other talks that you may have watched, or if you look up on Google other talks on functional reactive programming. I'm not focusing on the UI portions. I'm focusing on some other concepts. So hopefully you'll learn something new today. But if you want to learn about those, I encourage you to go to their GitHub repo, ReactiveCocoa, and read up on their extensions. It's already demo time. So this is the application that I've written. I mentioned that I work at Riot Games. In the game of League of Legends, you pick a champion to play. This application lets you browse through all of the champions that you can play in the game. And if you tap on a champion, it will display a list of the skins that that champion has that you can play. The other thing is to notice there's some magic floating around there. Do you see that? And I'll show you that for real here. So this is the application. So when you tap on a champion, like Alistar, you can see the skins. This is the default skin. These are the different skins that you can play. So this is a simple application. It has two views, both UI collection views, the champion browser and the skin browser. Now, there's a whole bunch of images that the artists have created that make this app look really cool, and I can take mostly no credit for. But I retrieve all these from an API that I've been talking to Peter about, and I think he's already been studying it because he's all excited about it. He plays the game. So I hit an API each time the application starts, and one of the APIs that Riot Games makes available, which I call RAPI, stands for Riot API, will tell me information about the version of the data that I can get from the API, and it matches the version of the game. Riot updates the game about anywhere from every 2 weeks to every 4 weeks, and therefore their API gets updated with new data. They release new champions and new skins very regularly. So every time the app launches, it goes out and hits these APIs, sees if the data that I stored locally in SQLite in my database on the device is different, and if it is, it resyncs all the data. All of this is displayed from data locally in the SQLite database. All the images are retrieved from Riot's content delivery network, and I derive the URLs for all the images from the data that I get from Yeah. So that's probably way more than you care about. The other thing I want to show you is when I navigate back, well, it didn't do it in that case. For that case. But let's see if I can get it to work. Okay. If I change orientations or I navigate back from viewing the skin images, you'll notice the magic in the background randomly changes colors. So, the actual magic and how I do that is not part of this presentation, but what is that I've applied functional reactive techniques and ReactiveCocoa to cause that to happen. So notice that. The other thing is that I have two UI collection views, and I use ReactiveCocoa to populate data for those views. So that's the demo app. I'm going to look at code here in a while, but let's get started. Okay. So here is what I'm going to talk about today. These 5 things are the concepts that are important for you to understand in order to start using ReactiveCocoa. We're going to start with the signal. So exactly what is a signal? Well, it's an indication that something has changed. Exactly what that is, it could be practically anything. It could be your user tapping on a button. It could be the user typing data into a text field. It could be the user swiping or scrolling or selecting a cell in a table view. It could be an NS user defaults value being saved or deleted or added. It could be an NS user notification. It could be a response back from a login service call, a success or a failure. It could be the result of a network call that you make where you get JSON data back or an error. It could be anything or all of those things. So something has happened. Now, a signal can emit one of 4 event types. And the first event type is the next event. The next event can carry along with it a payload, which is something that when the event is emitted, comes along as part of that. It could be anything. It could be the button that was tapped. It could be the JSON block, or the error that, well, no, it can't be the error. I'll get to that. The second type of event is the completed event. A signal can emit 0 or 1 completed events. So if and once a completed event is emitted, the signal is considered terminated and no other events are possible on the signal. The third type of an event is the error event, and it's similar in different ways to the previous 2 events. It's similar to the next event in that it too contains a payload, except that the type is some sort of an error. It's similar to the completed event in that there's 0 or 1, and once an error event is emitted, the signal is considered terminated. The last type of event, which in my practice and experience I have never used, is the interrupted event, and there can be 0 or 1 of those. Now, I talked about emitting things. On the other side, when these things happen, you can observe. So a signal can have, on the other side of it, 0 or more observers. Those are things that react to these events, and that's where the reactive portion of this comes in. When you observe a signal, it returns to you a disposable. Can anybody guess what a disposable is used for?
Is it resistance?
No. To dispose. So when you want to stop observing, you call dispose. And that removes you as an observer of any events on the signal. So let's take a look at this. Here's how we create a signal. Now, Brad spoke briefly about generics, thank you. So hopefully I won't have to that much. I'm glad to do it if you want me to. But here is a line of code that creates a signal. And generics are used to specify that the type of the next event is string, and the type of the error event is NS error. And I use the pipe function to return a signal, actually a tuple, which is something in Swift where you can combine multiple values. The tuple is the signal that was created and something called the sync. So when I was first learning about ReactiveCocoa this summer, I kept reading the documentation and reading it, and I could not get past this thing called a sync. I kept thinking of, maybe all of you already know what this is. I couldn't figure out what this was. So I kept thinking, like kitchen sink maybe, or I don't know what the heck this is. I don't know what it means. And to make matters worse, they also refer to it in the documentation as an observable. So those two didn't seem to go together, and I had a lot of trouble with this at first. So I finally decided to look it up, and what I found was on dictionary.com, the first part of this explains everything. So since I thought maybe some of you may have the same issue, I want to clear this up really early, and that is a sink is a device or place for disposing of energy within a system. And that's exactly what this is in ReactiveCocoa. So it is through the sink that the signal disposes of its energy, and its energy comes in 4 different parts, which is next, completed, error, or interrupted. So it is through that that it emits its events. Once I understood that, then that made it a lot easier for me to understand. So let's take a look at how we send an event. I have the same signal here, and I'm going to send a next event. I'm going to cause that signal to emit a next event. There's a global function called sendNext. I need to specify the sync because that's the way that it emits its payload. And I'm passing along a payload of type string. Now the compiler will complain because of generics if I don't pass a payload of string, because I declared my signal to have a payload of type string. So that's really cool. Very simple. The next thing, how to send an error. There's a global function called sendError. It also takes a payload of an error type. Here's an example of just sending an empty NS error. And finally, can you guess what sending a completed event might look like? There's no payload, so there's nothing to send. So the thing about signals is they emit events whether or not anybody is observing. So because of that, they're considered hot because they're always on. So whether or not a signal has any observers, if I or somebody invokes send completed or send next or send error, it will send that event to nobody. It's kind of like a tree falling in the woods. There's nobody there to hear it. How do we observe signals? Just told you about how to send. I have the same signal. There's a number of ways to do this. I am, in this case, observing independently 3 different events on the same signal. The first is an example of observing the next event, and I'm using trailing closure syntax to specify a closure that is passed to the observe next function. Do I need to go into what that means? It's okay if I do. No? Okay. So I'm passing a function to observe next as using trailing closure syntax, and I know that the next event emits a value. The compiler knows what type that is because of generics, and I simply print something out. So similarly, if I want to observe the completed event, I can do that. If I want to observe the error event, I can do that. So I set up my observers on the signal, and then here I use the global function to send next, passing. Okay. To send a payload of hello there, followed by a completed event. And what happens is, when I send next, my closure, my next handler gets invoked, passing in the value of my payload, which is hello there, and it prints it out. And then immediately thereafter, it sends a completed event, my completed handler invokes and it prints that to the console. So a very simple concept, how to observe signals. That's it for the signal itself. Talk now about some operations. So what are operations? Well, you can think of them as things that you can bolt onto a signal. You attach it onto the signal, and most of the operations impact the next event. Not all of them do, but most of them do. Some impact the error event. As an example, we can filter, we can alter, manipulate, or map the payload of the next event to something else. We can alter the timing of. We can combine multiple signals together into one. This might touch on something Brad was talking about where he was composing an API call where one thing would come back and then asynchronously something else would come back. There are operations that allow you to work with those and combine them together and do something only when they've all responded in some way. I can chain operations together, composing flows of tasks or logic that I want to perform. And most importantly, they're functional in that I can pass my own functions to these operations and they will invoke my functions. So let's take a look at a simple filter operation. By me standing here, am I blocking anybody's view of this? No? Okay. So here's an example of a signal that I'm creating. The payload of the next event is a football team, and you can imagine what that might look like as an object. It probably has a name, it probably has a number of wins and losses, maybe a schedule, maybe a roster of players. So I'm bolting onto this signal a filter which must return a Boolean. If you return true from a filter, it will allow the payload of the next event to flow through it, the filter. If you return false, it will block it and it will not flow through. So in this case, I am bolting on a signal, a filter operation to prevent any teams with less than 10 wins from flowing through. It receives, in my closure, the team which is a football team, and the compiler knows that. I'm then observing after the filter, and therefore my observer only gets invoked for teams that have more than 10 wins, and I simply print something out. Another example is a map operation. Instead of a filter, I'm bolting a map onto the signal, and same signal with the football team, and instead I'm returning something different than the team. I'm returning the members of the team. So therefore, the next thing that I do is I observe, and my observer, instead of receiving a team, receives a collection of members of the team. And I simply iterate over them and I print something out about them. So I showed you a filter and a map. The really cool part of Reactive Cocoa is you can chain these together as you wish to compose flows. And so here I have the exact same signal, and I first have a filter which filters out any teams that don't have at least 10 wins. To that, I've bolted on a map which maps to the list of team members that play defense. And then I observe, and then for those, I iterate over each one of those and print something out about them. Does that make sense?
You chain multiple ones together, like you then, well, I guess you're filtering inside your map.
Well, this is different. This is a filter on a collection, which works different. It's not to be confused with that,
So
but it operates
Signal
the same.
has like one filter and one map, and if you're kind of doing stuff with it, you just use the like just basic Swift filter maps inside of it.
Yes. So you can actually have multiple filters and multiple maps, and you can compose them however you want. But the compiler will keep you honest because it knows anything after this is going to be a collection, not the team. All right? Yes.
So what you're gonna get out of this whole thing is a list of members that play
On teams that,
have more than 10 members.
yes.
Thank you.
Yep, that's exactly right. So, I talked about the magic earlier, and the fact that the magic changes color randomly when certain events occur, like I rotate my device, or I navigate to the skin viewer and come back. And so I solved that reactively using a signal, and I want to show you that. So for that, we'll jump to Xcode.
I don't think we've got it.
Okay, so here it is. And I wanted to say for Kirby, I did this for you because of your new bifocals. I blew the font up really large. I can say that because I wear bifocals also. And they're progressive.
Yeah, and the progressive part.
Yes.
I didn't get used to.
Yeah, you're like doing this all the time. People think you're agreeing with them, but you're just trying to see. Okay,
We're looking down your nose at them.
yeah, more likely that probably. Okay, so here is a signal that I've created that has a next event that emits a UI color, and no error is a special Reactive Cocoa error that conforms to the error type that Melissa told you about. So it just means that this signal will never emit an error. So I use the pipe function, get my tuple, I keep those. Now here, I'm keeping a list of my disposables, which I get by observing. And I have an operation here, which I didn't talk about yet, which is called throttle. And throttle allows me to delay delivery of the next event. And in this case, I'm delaying it by 1/4 of a second. And that's because in the case when I'm rotating, I want the view to have time to lay out so it knows its new size, and therefore I present a new magic scene of the correct size. So I use sprite kit and scene kit, which we're not going to talk about here, to generate the magic particles. And all it cares about here is that when I'm observing this signal, all it cares about is, hey, I got a new color, I better present a new scene. That's all it cares about on the observe side. It doesn't know what caused it or anything, it's just watching for a new color. Every time a color comes down the signal, it says, I better make a new scene with this color and present it. And that's what causes the color to change. So this is all in view_did_load, by the way. So since I don't have an initial color, I have to first generate a new color, and I'll show you that code. Pretty simple. Right here. So I have an array of colors that I have predefined that are the possible colors for the magic, and it simply generates a random index, grabs the next color, uses send next, and when that happens, the observer code that I showed you just a second ago gets invoked with the new color and it presents a new magic. So it allows me to decouple both sides. Like, all I care about is when these things happen, I need a new color, and on the observing side, all it knows is when I get a new color, I better generate a new scene with that color. And that is what causes it to run when I come back or when I rotate. Oops, I went too fast. Okay, Yes, I did. This is a list of many or most of the operations that are possible in ReactiveCocoa 3. We touched on filter, we touched on map, and I showed you an example of throttle. I'm not going to go into these, so don't worry. I would bore you to death. But you can go to the ReactiveCocoa site and learn about all these. In particular, Brad is gone, but where is it? Maybe I didn't put it on here. So there's a combined, not combined previous. I can't believe I didn't put that on there. Combine, it's called combined latest, and it allows you to combine multiple signals into one, and it would not invoke its next observer until all three answer, or all, however many of them. You can have as many as you want. Okay, that's it for operations. So I talked about signals, I talked about operations. Let's move on to the signal producer. So exactly what is that? Well, it's just like a signal, except that you must first start it before it'll do anything. Just like the signal, same events. I left out interrupted because I never use it, but all the events apply. Same thing with operations. You can bolt any of the operations under the signal producer. The difference is that it's considered cold, in that it doesn't do anything until you start it. And in it creates a signal once you start it. Obviously, you probably figured that out because of the name of it. In my experience, this is the thing that I find myself using the most, not the signal. However, the thing that we're not going to talk about, which is all these UI extensions, those are mostly implemented as signals, always on. So if you're typing or tapping, those are firing no matter what, whether anybody's observing. And I prefer to use them in the context of actions, which I'm going to talk about in just a second. But first, let's see how we create a signal producer. So I'm using generics the same, except for the signal producer. And I pass to it, using trailing closure syntax, a function that will be invoked when it's started. And by definition, it has to be a function that declares two pieces of input, the signal and the disposable. Now, in practice, I've never found a need to use the disposable in this context, but it's there in case you need it. So what you'll typically do is, once it's started in this function, you'll go do something, like run a query, or go perform a network operation, or do some sort of calculation, or generate a random color, or whatever. And then, using the sync, you'll send one or more events. It's up to you what you send. You don't ever have to complete if you don't want to. It's up to you. But in this scenario, all I'm doing is sending hello world and then completing. Remember, that doesn't run until start. Exactly. You call start. So here's an example. I call start with next. This function allows me to both start and observe the event at the same time. So I'm passing using trailing closure syntax. You'll find that to be a common pattern with this. The function that will be invoked when the next event occurs. So by calling this, it causes that up there to run, followed by my observer. And in this case, what happens is, to the console, you get, well, hello world. Clear? All right, that's it for signal producer. Next up, the action. So what is an action? If you're not familiar with the command pattern, an action is ReactiveCocoa's implementation of the command pattern. And the command pattern is something I'm a huge fan of and I've used for many years, even dating back to my Flex days that Gene laughed at. And what that allows you to do is encapsulate a unit of work or a task or something that you want to perform inside of a thing that we'll call a command or an action that you can pass around, and then you can invoke it. You can cause it to run that piece of work later or whenever by calling something like execute or run, or in the case of actions, apply. So, commands can optionally accept input that may affect how they run. They can optionally produce output or something that they return, and they can optionally generate an error. So, for Reactive Cocoa actions, you specify the type of input, if any. If not, you specify void. The type of output, if any, and the type of error, if any. You invoke apply, passing the input, which must be of the type that you've specified for the action. It, by definition, must return a signal producer, which we just learned about, which can then be started. And the next event of the signal producer matches the output type of the action. So it's used to perform tasks reactively. So do something, and then because it returns a signal producer, I can react to it, whatever it does, whenever it happens. So you do things like perform queries and make network requests. And in that regard, it seems very ideal for what Brad talked about. Maybe using them in conjunction with MVVM and putting Reactive Cocoa behind these view models that he talked about. And I think he even said you often, if you go read or look this up on Google, you'll often see the two of them talk about in conjunction with one another. So let's take a look at an example. Here's an action that returns to me a count of skins for a specific champion. Now, I'm sure all of you have dealt with table views or UI collection views, and there's two things that really you must provide in order to be able to render those. The first is, how many things are there? And the second is, when asked, make a cell for one of these things. So one of the things I need to do is get the count for a champion. When you tap on a champion, the first thing I need to do is figure out how many champions there are so that the system knows how many cells to ask for and how big to draw the scroller. So here's an example. I'm declaring an action using generics, the input type, the output type, and the error type. And the compiler will help enforce and keep my code accurate or error-free as I write it here. So, I'm using the default initializer, trailing closure syntax. Remember that I said it must return a signal producer. And this code in this function runs when you call apply. And the input to that closure must be of the type for the input declared on the action. So it knows that champion key is a string. So all I do here is I run a query and I return, I emit over the signal, or over using the sync, the count, the number of champion skins for this champion. And then I complete it. Remember, nothing happens until you call apply. it returns a signal producer whose output or whose next event type matches the output type of the action, and whose error type matches the error type of the action, and then you call start to run the action. So let's take a look at how we do that. Same action, I call apply, passing a champion key. That causes that code to run, which still hasn't run the query yet. It just returns a signal producer to me. Then I call start with next because now I just have a plain old signal producer. I start it and observe the next event. That causes that code to run, which runs my query, which causes it to, whenever it completes, emit a next event, which is the count of skins for that champion, and then I simply print them out here. Okay, so in summary, on an action, you call apply, pass the input, it returns a signal producer, and you call start. Last thing I want to talk about is the scheduler. So as we've already talked about some of the previous speakers today, I think maybe Brad as well, doing things in the background. Well, schedulers are Reactive Cocoa's implementation of concurrency. It's very common, as we've already discussed, to do things like run queries or perform network operations on a background thread and have those results delivered to you on the UI thread. And schedulers are the way to do this. Schedulers use dispatch queues, which, is everybody familiar with dispatch queues? Okay. There are three types. There's a UI scheduler, which is the mechanism to run code on or observe events on the UI thread. And as a mobile developer, we all know one thing. Like the old man says, stay off my lawn. You stay off the main thread as much as possible, right? Otherwise, your UI is choppy or freezes or whatever. And you make your users mad. The second type of scheduler is called a QueueScheduler, and it is the mechanism that ReactiveCocoa uses to do things asynchronously on background threads. And the immediate scheduler is the third type, and it runs things synchronously on the calling thread. I have really not used that one that much, but I use the other two all the time. There's two functions that allow you to control threading and concurrency. There's actually a couple of operations that work with this as well, but in terms of running the work, causing certain things to run on a specific thread, SignalProducer has a start on method function that you pass a scheduler to. So if you want to run something in the background, it's as simple as that. Signal and SignalProducer both implement an observe on function, which you pass a scheduler to, and it will instruct that to deliver the events to you on that schedule. It doesn't have to be the UI thread, it could be whatever scheduler you want. So how do we do that? Very simple. The first thing we do is we create a dispatch queue, and in this case, I'm creating a database queue that I want to run all my database operations on. It's a serial background queue. The next thing I do is I create a scheduler with that queue, and then I use it. So it's as easy as that. So even though I had this action that was the way I showed it to you before, it was running everything on the UI thread, I can use these new things to run them concurrently. So I call apply, passing my input. That causes a signal producer to be returned to me. And that is when I can use start on, passing my background queue scheduler, and then I can tell it to observe on the UI scheduler. So with 2 lines of code, I've been able to make that operation, that action, asynchronous and deliver the results to me on the UI thread. And then I start, which causes the query to run on this scheduler, and when the next event gets delivered to me, this runs on the UI thread.
Since the get skin count action is the code that knows that it has to run a query, can it call start on the producer that it returns so that it makes sure that everybody, whoever uses the get skin count action, is going to have it run on the DB queue?
Yes, but
People don't do that.
I typically don't do that. So what I like to do is I like to declare all of my actions outside of my view controllers. Like, these are all the things that you can do. And in my data sources, that's where I call start on. Okay, so you can do it however you want. Yes, if you want to do it that way, that means whoever calls it always has to call, will always run that code on the DB thread. If that's always the case for you, then you're certainly welcome to do that. So I typically organize my code where I have all my actions, I identify all the things I want to do, and it's really nice to be able to organize and identify all the things that my view controllers can call, invoke, and then I also have signals, so which generally are signal producers, so things that can change without me having to worry about them. I will observe those as well. Okay, so last thing I want to show you is how I used Reactive Cocoa 3 and functional reactive techniques to run queries, get the data for my champion browser and for my skin browser. They're both the same, so we're only going to look at one. Using actions and signal producers and schedulers. So for that, we'll jump back over to Xcode. Am I doing okay on time?
More or less.
Yeah, you're fine. What time am I supposed to? What time am I supposed to end?
4:15.
I practiced this so many times and I finished in 45 minutes.
It's 3:21 there.
I'm going to blame this on Brad because he's not here. Okay. So this is in my view did load. It's a common pattern using these techniques to go set everything up in view did load or view will appear, or I guess for watch OS, whatever that's called. Will await. Okay. And then to tear all that down to dispose of everything in view will disappear or view did disappear. So I know that I need content for my UI collection view. So am I looking at the right thing? This is not production code.
Okay,
This is my own app that I wrote.
okay.
Yeah, I would be fired probably by now. I was showing you the wrong thing. This is in view did load. So here, I go to my data source, which is a separate class, instance, whatever, and I have a get content signal, and I observe on the main thread here. And then whenever, this is, in this case, we'll look at this, but I'm getting back a tuple as the payload of my next event, which is the count of champions and a result set, a query result set, which is all of the data for all the champions that I want to display. So I need those two things to render my collection view. So let's go look at that, which I mistakenly showed you first, which is right here. So I do things slightly different than what I just showed you in the slides, but that's because this is slightly more complicated than that. I return a signal producer that declares that it returns a tuple, And the first value of the tuple must be an int, and the second value must be a database cursor, which is a result set from a query. And so I simply have an action, which gets me the count, and these run synchronously on whatever called them, whatever thread called them. And then as soon as I get the count, you'll see I do that same technique that I showed you about actions. I apply, there's nothing to pass it, because I just want to get a count of the total champions. And then I assign that to my variable up there, and then I perform a query to get all the champion data that I'm going to display, which is the name and the key and the URLs that I'm going to use to display the images. And I run that and assign the cursor, and then when that's done, I send a next event with the tuple of both the count and the cursor. And then I say, you're done. And notice here is where I say start on. Because I always think, in my view, it's best to let the caller indicate how the asynchronous model operates. So the caller of this, which is this code in the data source, determines that this is to be run on the database scheduler, which is a background queue. Last thing is the action itself, and they're both similar, but here we go. And I'll make Melissa proud here because I have a defer statement. And a try and a catch. Yes, so what I'm doing here is I declare my action, void input, int output, SQL error. I return a SignalProducer by definition, which outputs a count, and then I use try because this is a throws. This is a throws function. We won't worry about that. That's beyond the scope. But if you care, there's all kinds of cool stuff in this app. I use it to play around with a bunch of tech. It runs a query that returns a cursor. I use a defer because I want to close the cursor when this function is done. And then I go to the first row in the result set and get the int at the column called the count. And I send that as the next on my signal, which gets the count, and then I complete it. And notice here that if I error, I don't do any of that, and I send an error instead. So, getting the champions is similar. I have another action. I think I'm way over time, but you can get the code and look at it. I think that's it. All right, I guess that's it. Thank you very much.